All right, everybody, I am getting ready. Jim is just getting in. He was on mute. Now I don't know if he's going to be in or not. We are live right now on TubeLand. So thanks for joining us. We're going to get started. We're going to be talking about methods to reduce the likelihood of shock. Mr. Dollard is getting logged in. Get your 70E book out. Get your 2020 code changes book out. You're going to probably need those. I don't know, Jim, are you in? Uh-oh. Not sure why you can't hear me. Hold on. It might be on my end, Jim. Hold on. Let me look at my... No, I'm talking. So it's not on my end. Let's do this. I'm going to give you a call.
Yes.
So you can hear me, but I can't hear you.
Can you hear me now?
I can hear you over the phone. So I think we could just do this. We'll do it over the phone, and I have your video, so we're good. You can see my computer screen, right?
I can see your computer screen.
All right. I think there's a little delay in the. Your lips are moving, but I can't see what you say.
Yeah, well, I did everything I was prompted to do. Maybe it was the shark.
All right.
We had to do this last time.
Yeah, we did. Absolutely. I remember that. It could be an Apple thing. You never know. You have an Apple, right?
Yeah. Well, it's a Mac, but you could call it an Apple.
Oh, man. Well, what's it look on the outside of that cover? What does it look like?
There's a giraffe.
It's an apple.
Not on mine.
Not on mine. All right, so I got the presentation up. We're showing the sign in right now. I'm just going to look at the different views and make sure that everything is looking good. I got to go to, if I go to live and then guest, I think. So I'm going to close this. I don't need to do anything with you there. Should I mute my computer, or do you have your things muted, or are you listening to me over the phone?
I'm listening to you over the phone because I just couldn't. I could hear you on the computer, but you couldn't hear me. And all of the functionality was there. I would mute and unmute, but you still couldn't hear me. I raised the volume. It still didn't work.
All right. Wonder why. We could try Teams. Did you ever do Teams? Microsoft Teams?
No. I don't know what that is.
All right. Well, that's okay, I guess. We can live with that. All right. So I threw some more slides in there. Let me show you what I've got. I'm going to.
So this actually starts at 2:30, right?
Yes, it starts at 2:30.
Well, you want me to try to sign in again?
Yeah, I was gonna say you want to let's do, we can do that, or I can try to send you a Teams invite.
So all right, I'm gonna hang up the phone and send me whatever invite it is, and let's try this again. So it'll that way we won't have the delay.
Yeah. All right.
Yeah. All right. Bye.
Bye. All right, we're gonna try Teams. Where is Teams? Teams. Teams. So I'm gonna get out of this. See, this is why we come in earlier, because we want to make sure that this stuff is working. So I'm going to close that. End meeting. And there is Teams. All right. Oh, I don't want that. I want to go to Eaton's Teams. I'll bet you Teams will work better. I don't know. He may have to install something on his side. Teams. Calendar. Got to go to calendar. And then I go to Meet Now. And I say Join Now. Remember your book. Just saying. Copy join info. Copy clipboard. Copy clipboard. I'm going on email. Me. Jimmy Dollard. Link. Control V. Send. Just sent you a link. Good stuff. We're going to see if he can get in. If you can, he can. If you can't, you can't. And we always can have our fallback where it'll be like this. All right, this is what I said. Welcome. So right now, if you're dialing in on YouTube, I haven't checked the YouTube. I don't know how many people may or may not be out there. Oh, I got a thing. Jimmy's trying to come in. Where's he at? I'm admitting him.
Can you hear me?
Oh yeah, I can hear you. Can you hear me? Oh, hold on. Go device settings. That's the setup. Speakers, microphone. Yeah, hold on. I can hear you. Hold on.
You are muted.
Yeah, I know.
I can see the line through your microphone.
He is something else.
I can see the line through your microphone.
I know.
It's on the lower left of my screen.
I know.
And I got a block in the middle. It's got a camera, a microphone. You should have the same thing.
Camera.
You're muted.
Yeah. I'm gonna look at sharing screen number 3. I know. Working on my audio. More actions. Turn on keypad. Turn live.
I still can't hear you.
I know. Hold on. Show meeting notes. Okay, camera none. Private view. Yeah.
Your microphone still has a line through it.
Yep. Show meeting notes. No microphone was found among your devices.
hear me?
Yes. Yes, I can. Yes. Yes, I can. Trying to work through and figure out why my microphone's not being recognized. System audio.
Click on the participant button and your name will come up on the right. And maybe you can unmute that way.
Can you see my screen?
All I see is a circle with your initials.
Wait a second, I wrote these. Okay. Oh boy. Well, see, this is technical stuff. Yeah, Nihad, it's right. He is having the same problem. Okay. Back to WebEx.
Okay, I will.
Whoops. Hung up on him. Closing that. We're going back to WebEx. The only problem I had with WebEx was there was a slight delay in his audio, and we couldn't hear him on his side. The notification tone in the background is normal loudness, whatever that is. I just saw your note, Mr. Froming. Can barely hear you at all. Okay, hold on. I'm trying. I'm giving it the old 1-3. I don't know why. Pulling this up. And then maybe this call in using, let's go back to settings, microphone, speakers. Okay. Same WebEx link as before. Oh, there he is. Okay, can you hear me, Jim? Please say yes. Oh, Jiminy Crickets. Why can't I hear you? I'm not muted. And you're not muted. It's doing the same thing. I wonder if you if you hit those three little dots, there's a link in there called audio connection. And then you can hit change settings. And when you hit change settings, you can pick the speaker. Like I have microphone USB, which is my USB, and then I have my speakers. See if that, can you change your set points there? I believe you can hear me. There you go.
What I did, I called in.
Ah, there you go. Perfect. Now try to share your video.
Share my video. All right, hold on a minute. Start, put the lower light on the side.
What?
The Miller Lite, so I have to move the Miller Lite out of it.
Yeah, move the Miller Lite and the Scotch. There you go.
There's still no Scotch.
There's perfect.
No Scotch. Just me.
Oh, geez, that was on YouTube.
Was it?
Yeah. Jeez. And you know what? You know what I learned is I can't edit some of this stuff out because when you edit it out, I learned that you lose the all the chats. I couldn't figure out why there's a lot of stuff that goes on in chat, which is very valuable. And for the last couple, I've not been able to see it. So change from top chat to live chat. We can hear you now. All right, Todd Save, Nihad's on. Now we can hear you. So I am for some reason my microphone, it's got to be right next to my mouth. And
Just get some duct tape.
now let me ask you a question, Jim. What does ROFLMAO mean?
I don't know. Where do you see that?
David Engelhardt just typed in ROFLMAO. I think I know what it's. Laugh my ass out, but ROF? I don't know what ROF is.
It's rock. I'm not going to say the rest.
Yeah. Good afternoon from Kansas City. Lisa Coyen, thanks for joining us. Steve Froming's out there. You know Steve Froming, right?
Hey, Steve, that's 13.
Yeah. You know Nihad El Sharif? CMP. David Engelhardt. Boy, that's a nice chair he's got. A DXR Acer. Is that a gaming chair?
A gaming chair, yeah. My kids each have one of these, and I sat in them, so I bought one of these for my office chair because these things are just incredibly comfortable.
Nice. So
you get really good back support.
So I have your title as Safety Coordinator Retired. Is that right? What should I put?
Yeah, Safety Coordinator Retired. I'm retired.
Man.
I get pulled into things like this on a holiday weekend.
Gotta love it. Hey, it's the least I could do. You do less for me, right?
That's exactly what I do.
Oh, man. All right. Well, we got 15 people out there, 220 right now. So I got I added some more slides in there around what did I add? I put a couple more pictures in. I added the risk assessment stuff and risk.
Did you put the picture of Nihad in?
No, I you know what? I couldn't find it. What else do I got? I have I threw in some stuff. There was something else I added. Oh, some stuff on the one-line diagram. Because I think that's going to be a key. I threw in some references to 70B. I put that stuff over in around the, I think that's in the maintenance area. Oh, you know what I didn't put in there is the reconditioned equipment stuff. We can have the discussion, though.
Well, we can just, there's a lot of moving parts there, too.
Yeah. Oh, and what I'll do is I'm going to get the code book open. I got to lift this microphone. I hate the fact that I got to put this right in front of me. All right. I'm going to bring up the code book. NFPA.org/70. And we are continuing ShockWeek. Jim's audio is way, way too low. I can probably try to get your audio up, Jim.
You can probably raise it here too, I think. I think I can make a little modification on it.
Okay, try it again.
Is that any better?
Oh, perfect. Yeah, you know what? I had you muted. It was only coming through my mic.
Right, yeah, you had me muted last time. That's why we had to do this time.
The best Jim Dollard is a muted Jim Dollard.
There you go. There you go. Imagine what the code would look like if they could get me to shut up.
Oh, absolutely. All right. So I'm asking the guys out in YouTube land. Does Jimmy sound a little bit better now, Nihad? Oh, ROF. Bruce says ROF is rolling on floor. That's
Rolling
what it is.
on. Oh, there you go.
Yep. There we go. Rolling on floor. Thanks, Bruce. Jim's audio is way too low. Hopefully they can get you better now.
I learn something every day, and that's something.
Yes. All right. I've got to do that. And hopefully that didn't hurt anything. And I've got to do that. There we go. All right, we're getting there. So we got about 5 minutes or so. For some reason, my computer is 2 minutes off from my cell phone. I don't know why. I give up on technology. Better, but could be up some yet to match mine. What do I bring mine down to match his? Let's do that. There we go. There we go. Actually, I can move mine away. So I'm a little bit lower, but not as loud because I tend to get excited. All right. So I think hopefully.
Wasn't that Warren Zevon?
What say what?
Warren Zevon.
Warren Zevon. What's that?
He had that song, Just an Excitable Boy. Remember what he just said?
Yeah, I didn't know he had a song like that though.
He did, yeah. Well, you can talk to Alexa when you get done and have her play it for you.
Okay, I'll do that. Don't say her name too loud because she responds no matter what.
Mm-hmm.
All right, so I have to. I am going to just double check some of my things here. So for those of you on YouTube, the Menti code is down below. Use that to sign in. And woo, almost dropped serial number 1 ShockWeek official mug. You know what I'm going to do, Jim? I'm going to put number 1 on the bottom. And it'll be serial number 1. And I'm thinking in maybe, I don't know, maybe 4 years on eBay, it's going to go for a heck of a lot of money. What do you think?
I think it's wishful thinking there on your part.
Oh, man.
Unless Jaws comes back, and then if Jaws comes back, maybe, if it makes a resurgence, or if Netflix does a series on sharks, then maybe it'll pick up.
All right. So what time is it? It is 2:20. We still got a couple minutes. I don't want to be too early, but yet I don't want to be too late.
That's right.
Stage. And I got to get back to the Menti code. So the Mentimeter code is down below. Enter that. The way for those of you who may be joining us that hasn't joined us before, we do a Menti code at the beginning. I do a Menti code at the end, which is different than the one at the beginning. Anybody who fills that out will get a professional development hours, 2 professional development hours, and will be entered in a list to win an official ShockWeek mug. whoever gets serial number 1 is going to probably make more money off of this in the years to come than the guy who has serial number 2. Just saying. All right. All right. So Bruce, let's see. James equals better now. So you're sounding good. You're sounding better. Kansas City in the house. Andrea Odrowski, thanks for joining us. Although Jim should close his blinds as the contrast is going up and down is distracting. Man,
it is distracting. I'll just have to shut my video off.
No. We want to see you. In fact,
Yeah, because that's just a series of windows above the door. And the only way I could do that would be to put paper over it or something.
Yeah, you're fine.
And I'm just not going to have the time to do it. I'll just point this up.
Yep, you're fine. James T. Dollard. Okay. Well, it's what time is it? I got 2:30 on my end. So I believe we are now. Let me get, I got to get us over to 3 tight. There we go. All right. So welcome to the continuation of ShockWeek. Huh?
How come I don't see your screen? All I see is your initials.
Oh, hold on then. You should have said something a long time ago. That means I didn't share it out.
I thought you were just waiting until you got started.
No. Okay, here we go. I'm going to share out screen 2. And then I'm going to have to make you big again.
There it is.
Yep,
there it is. I see that. I call it a bar napkin shark.
A bar, you know what? And basically, so how I drew that, I have this, this new Elite book I have has that pen associated with it. So I was sitting on the side porch with Bobby Joe, and we were each of us were drawing sharks, and that was the one that won.
There you go.
All right. So now we're gonna start ShockWeek, not Shark Week. ShockWeek. So welcome to ShockWeek, the continuation of ShockWeek. We are going to be talking about methods to reduce the likelihood of shock today, or for the next 2 hours. And with me is Mr. Jim Dollard. And Jim, why don't you? I could not come up with the whole list of stuff that you've been involved with and are involved with. So why don't you just do a brief introduction?
All right. I am the retired safety coordinator from IBEW Local 98 in Philadelphia. So I've got 40 years in the industry, and I'm still very active in the industry. I started in the NFPA code revision process in 1996. I was a member of Code-Making Panel 15, chaired Panel 10 for 3 cycles. I'm still on Code-Making Panel 10, which is purview over overcurrent protection. I'm on Code-Making Panel 13, which is a wide range from batteries to fire pumps, emergency systems, legally required systems, optional systems, COPS systems, and much more. And I'm a longtime member of the NFPA 70E committee and a member of the UL Electrical Council. I am also a master OSHA 500 instructor for the ETA through CPWR. So when it comes to electrically related requirements for safety, I have had the privilege of being at the table as it has changed over the last couple of decades. So it puts me in a unique position to be able to share it with you.
Yeah, absolutely. And very, very happy to have you here. And like I say, you and I did a program, which I'll provide a link later up above to our previous, I believe it was on 70E. It was Arc Flash, wasn't it? I believe our focus was. And
yeah.
Yep. So we did another program, which I'll put the link up there. So anyway, We're going to be talking methods to reduce incident energy, or I'm sorry, electric shock, because our focus is on shock. And you know, Jim, I think you pointed this out to me. You taught me some things about Annex K in the 70E book, which highlights a lot of good statistics. And you did say you're on 70E, right? You told them that?
Yeah,
Yep.
I'm a longtime member of that committee, yes.
Yep. So there's a lot of good statistics in informative Annex K, and I know we have some of that in this program. But we wanted to start off talking about risk and the risk assessment, because that's got to be, as part of all of our projects and jobs and whatnot, we have to do what we call a shock risk assessment in addition to an arc flash risk assessment. And so, Jim, what are your perspectives on the topic of risk?
Well, risk is defined in NFPA 70E, but let's start off at 10,000 feet and let's take a look at any venue where we need to provide safety, electrical safety, and there's really three ways that you're going to do that. So our main focus today is going to be on the installation code. So there has to be a sound installation code, and we have one. It's the National Electrical Code. Second, there has to be a work practices standard, a standard that provides men and women that during their daily activities will expose themselves to energized conductors and circuit parts. There has to be electrically related safe work practices. We have to provide that for them so that they can work safely while they're exposed. And then product standards. We have to have all three. So really what we're talking about today is a hazard, right? And 70E defines a hazard as a source of possible injury or damage to health. So when a hazard like a shock hazard or an arc flash hazard exists, then it's there. We don't do a risk analysis. NFPA 70E used to call it a hazard risk analysis. We don't do a risk analysis of the hazard. The hazard is there. So we qualify the hazard. We understand what it is. But what we're dealing with is risk. And, so we're looking at what we're doing, our activity, and how it could relate with that hazard, and is there a likelihood that we could get injured. So let's take a look at the definition of risk in NFPA 70E. And just back up one time. So it's a combination of the likelihood of occurrence of injury or damage to health and the severity of injury or damage that results from a hazard. So what we have to do is we first take a look and we say, is there a hazard? So, we'll just look at risk and, is there a hazard? Is there a shock hazard? Well, first we look at the likelihood of shock. We look at the likelihood of occurrence, and then we take a look at the severity of injury. So if we got a bell battery, that's one thing, and we can't get hurt. We got a 277-volt circuit, that's going to be completely different. And then we roll risk into the definition of risk assessment, and that's next.
All right. So,
and this, yeah. Go ahead, Tom.
So you sit down and say, like, where it says likelihood of occurrence of injury or damage to health. So first, I could sit down and say, and I could eye up a situation that I'm going to, I don't know, hammer a nail, right? And I could say I could hit my thumb, and that would be the damage to my health. I could say I could hit my thumb, and depending upon how hard I hit my thumb, that would be the severity of the injury. But I would never die because I hit my thumb with a hammer. So I'm assessing, number one, I could get hurt, and then number two, the severity of that injury, which could be death. It could be that I just get stitches, right?
Exactly. So first and foremost, the likelihood of you hitting your thumb with a hammer is extremely high. So that's the first piece. You have to take a look at the likelihood of injury or damage to health. Then you take a look at the severity of injury or damage to health. I mean, you could break your thumb, you could, really hurt yourself, but you're not going to kill yourself. Right. That's not going to happen. And likelihood is a term that we use in 70E that trips some people up. And when we say likelihood, we're not saying that it's not possible. Anybody that's listening to us right now, right where they're sitting, is there a possibility that a meteor enters the Earth's atmosphere and by the time it makes its way to their home or their place of work, it's the size of a baseball and punches right through the building? It's possible. It is certain, but is it probable? Is it likely? The answer is no. Everybody that's listening has gotten on a flight and gone somewhere on vacation. So let's talk about getting on a plane. Is there a possibility that the plane goes down while you're on it? The answer is yes, but is it likely? The answer is no. So we always have to take a look at likelihood. And we tell you in the standard when we get into, for example, table 130.5C and 70E, that likelihood of occurrence is just one piece of a risk assessment. You must always look at the severity of injury or damage to health. And the example that I'll give you there is, is there a likelihood that there is a failure closing a 400 amp molded case circuit breaker? No. But if it does, okay, what's the potential severity? That's completely different than a 4,000 amp low voltage power circuit breaker at 480, 277 that's supplied by service equipment. So you always take a look at both. But the definition of risk assessment is really, really important in 70E, and it's something that we all need to think about anytime we're dealing with a hazard. So first, think of the last time you did a risk assessment. Well, I'm going to tell you, you do them all the time. And you've done them today, you did them yesterday, your family members do them, but let's walk through it. A risk assessment is an overall process. And what that tells us right there is that it's not one step. There's multiple steps to performing a risk assessment, to doing it right. And in NFPA 70E, there's two types of risk assessments: shock risk assessment, that's what we're talking about today, and arc flash risk assessment. So it's a process that identifies hazards. So for example, we identify exposed, energized conductors or circuit parts. Then we estimate the likelihood of occurrence of injury or damage to health. So what we're looking at now is our task. And we say, okay, is it likely that we put ourselves into a shock situation and get current flow through the body? Then we estimate the potential severity of injury or damage to health. And, it would be, a 120 volt circuit would be dynamically different than one leg of a 4160 volt or 5 kV system. And then we determine if protective measures are required. That's the last step. So everyone on the call has done risk assessments, and a risk assessment that you may have done, but you've certainly seen done, is somebody's driving, they're going 60 miles an hour, and their phone dings, and they reach for their phone, and they got their thumb over it, they're trying to open it, but it won't open. They're going 60 miles an hour, and now they got to punch in a 4-digit code. Can you identify a hazard? I can. It's called distracted driving. So what's the next step that that person does? And they know it too. What's the next step that they do when they're performing a risk assessment? They estimate the likelihood of occurrence, and they do it subconsciously, they do it instantly, and they do it based upon experience, and they make a determination that there's no likelihood because they do that all the time. So now, after going through that, now you're in the head of the wireman. And the wireman walks up to a panel board with a screwdriver in his pocket. He identifies the hazards, but he takes that dead front off because based upon his experience, he feels that there's no likelihood of an occurrence.
Yeah, and I think sometimes there's a lack of understanding of what the true consequences are, or that, that evaluation, we diminish the consequences. Like, for example, if I'm looking at a ladder and I've got to climb up a ladder, and you and I talked about this the other day, that, okay, so, I'm going to try this ladder out. I may get on that ladder, but you may go, there's no way I'm going to get on that ladder, because the consequence. If you fall, you could break a leg, you could break your back. There's people that have died falling off a ladder, a 6-foot ladder, right? Depending upon how you hit. So, and then you have other people that would do things that you wouldn't think of, where they're actually getting themselves into a precarious situation. Put stacking ladders on other things, and then you have the whole I ride a bike, and do I wear all of my protective clothing? Did I wear my boots? Did I end up putting partial PPE on, right? Because every time you do stuff like that, you're accepting some level of risk associated with that activity. And then there's the ultimate. What?
And a good example, Tom, a good example today, right, with COVID-19 is wearing a mask.
Oh yeah, that's true.
Some people, they claim, they're going to go out in public and they're doing a risk assessment. And they're not just doing a risk assessment for themselves, they're doing a risk assessment for their loved ones, because if they don't wear it and catch it, they're bringing it home.
That's exactly right. And then that's the ultimate. You remove the tape off of my mouth, and then you never know what you're going to get. It's another bad thing.
Yeah, that's a good picture.
But so Annex K gives us some statistics, and whenever we talk about safety, and I had this discussion the other day, that when we talk 70E, everybody wants to talk about arc flash, and I think it's because of the big booms and all of that good stuff. And I think Nihad and I were talking about it again on Monday as well. But when you look at the statistics, shock is way up there beyond an arc flash event.
Yeah, and keep in mind, this is right from Annex K, and it was updated in 2018. If you own a copy of NFPA 70E 2018, know that there's a significant amount of really good information in the annexes. And Annex K is a good one. Annex Q for human performance is another very good one. It's a very, very good read. But keep in mind that this is 98% of fatal occupational electrical injuries. It doesn't mean that this is the percentage of electrical workers. This is occupational electrical injuries. So a lot of these are 5 kV, 15 kV incidents with painters and roofers with metal ladders and metal poles.
So it's not just electrical workers that are in that 98%?
No, it's occupational injuries. It's all rolled in. There's no way to get, from a national database like OSHA, empirical data, that, you can get some, but it's difficult to glean it out. We can glean it out to some degree per trade, but the method of filing doesn't always nail down what trade it was.
Right. And they do talk about it could be electrical or non-electrical workers, but it is a worker. This would not include like me and my house getting electrocuted.
No. This is only workplace injuries, and it's based upon a review of data that was available between 2003 and 2009. Okay.
Yeah, and then again, there's so let me ask you. You brought up informative Annex Q, which talks about human performance and workplace electrical safety. And can you just give me a little background of the discussion from a 70E perspective? Whenever they put that in, what's that pertaining to?
Well, one of the up front in Article 110, which is general requirements, you get into 110.1, which is your electrical safety program. And then in 110.1H, we get into a risk assessment procedure. You're required, each employer in their written plan has to develop, and it's very easy to do because we give it to you, a risk assessment procedure. But part of that risk assessment procedure has to take a look at the potential for human error and the impact that it would have on people, equipment, etc. And human error can take on a lot of forms. As soon as you say human error, people think that happens at the point of injury. It was the individual performing that work did something wrong. That's not always the case. In many cases, human error occurs upstream, 1 or 2 levels of management above that direct activity that should not be performed in an energized state. And another area that human error comes into play is that in some cases, we've got individuals in the workforce, in a crew, in the company, and we know they're going through some tough times. There's illness in the family, or they're going through a divorce. They may not have their their head on straight, we certainly don't want to put them into a position where they could make an error, and it would be contributed. Human error is a significant contributing factor when we do investigate incidents, but it's not always the individual that was performing the work. And one of the key takeaways from Annex Q is that they tell you that right in there, reinforcing employees and basically praising them for doing things right is the most effective way to eliminate human error.
Wow.
We have a tendency as human beings to always just point at people and say, you're doing this wrong, you're doing that wrong, and you're doing this wrong. If we did that to our children, they would grow up and they would think, you know what, I can't do anything right. So we have to, when they do things right, we have to say, fantastic, great job. And if there's something they need to tighten up, well, then we have to get them to tighten it up.
So do you think that it's a good thing? I know a lot of people will initiate I think it's called a close call or a near miss, and they reward people for bringing near misses to their table, from an awareness perspective. I think there's people on both sides of the fence. Is that a good or a bad thing?
Well, that's very hard to capture. It's human nature. I mean, if we were working in a crew, 4 or 5 of us, and something bad almost happens, it's likely that we look at each other and say, don't let the boss know. We don't want him to know. The most effective one that I ever ran into was a line company. They do a lot of line work for local utilities in this area. They knew there was near misses going on, so they implemented. It's all third party. It's anonymous. Everybody has the website. But if a near miss occurs, they can go on to this website. It's anonymous. They type up the near miss, and what happens is they identify a charity. And then when that goes in, the safety team, they'll get it. They'll go through it. And if it's a valid near miss and it's something that they need to address, it becomes part of the tailboard. So that's their toolbox safety talk the next morning for every crew, and they donate $500 to the charity that individual named. But nobody ever knows who sent it in.
Yeah. Okay. All right. We'll move on. Misperceptions. Talk about that.
Yeah. This same study that was done from 2003 to 2009 took a look at these occupational injuries and found out that 40% of the electrical incidents involved 250 volts or less. And the determination there was that there's a misperception of electrical safety as a high voltage issue. As a wireman, with years of experience in the field before I began teaching full-time, getting into codes and standards and safety, I understand the mindset of the wireman. They will approach a panel board, for example, at 208, 120, completely different than they'll approach a panel board, an energized panel board, at 480, 277. They've been bit before. They've had current flow through the body before. They don't want to get 277 or line voltage at 480. So there's a perception, for some reason, that 120 volts isn't as dangerous. For example, under the right conditions, it's July. You're sweating. Your jeans are wet. You're on wet concrete. You're kneeling down. Yeah. You're dealing with energized conductors, and you get an equipment grounding conductor in your left hand and an ungrounded conductor in your right hand. You get to the let go threshold. You fall into the wall. Typically, when somebody gets a shock like that and hung up, they're on a ladder, and gravity is the method of release. But if you're kneeling and you fall into something, there is no method of release. So, the misperception piece is that electrical workers believe that 277, for example, is far more dangerous than 120. It has nothing to do with the voltage. It has to do with current flow through the body.
Yeah. Yeah, and we talked about that on Monday a little bit too, and I brought some of those slides forward as well. But like you say, the control of the amount of current that flows through your body is just limited by the circuit, whether it's 120 volts, 480 volts, 277 volts, whatever it is. It's the current that's going to cause your heart to go into defib, etc.
Yeah, now this next slide, anybody that's involved in safety has seen what they call, and there's a name for it, it slips my mind right now, but it's a safety triangle. And, it's data driven, and we know that it's true. So basically for every 300 injuries or 300 recordables, okay, and when you get an injury, it's a recordable, for every 300, it's basically one fatality. And the data bears that out. You can't argue with it. So there was a study that looked at data from 2003 to 2009, and there was over 1.7 million fall injuries in that time period, wow. And over 5,000 of them were fatalities. And falls are the #1 killer in construction. So when you run those numbers, there was one fatality for every 325 injuries. And that's pretty close to the safety triangle. But in the same time frame, from 2003 to 2009, there were over 20,000 electrical injuries recorded, of which over 1,500 were fatalities. And when you run the numbers there, it's an eye-opener. Mm-hmm. And there, one worker died for every 12.7 electrical injuries. Wow. If that doesn't make somebody that is involved in safety sit up a little bit straighter, then nothing is going to. And it's data driven. This isn't something that somebody made up.
So that's why they call the recordables from an OSHA perspective. They have recordables, recordable events, and then outside of the recordables, a contractor may, Don Ganir made the statement. He says some people call it a near hit. Whether you call it a near hit or a near miss, how many of those you have can tell you about when you're probably due for either a fatality or some serious injury, right?
Exactly. And keep in mind, these are just the injuries that were treated, which means somebody got shocked, fell, hit the floor. Typically, the average electrical worker gets shocked and, they're hurt, and somebody else sees them and says, "Hey, are you all right?" I can tell you what they're going to say. "Yeah, I'm fine," because what's really hurt is their pride.
Yeah.
And in most cases, they're not going to seek any medical attention at all. They're not going to fill out an accident report. They're just going to go about their day.
Yep.
So, I mean, we see a lot of those incidents go unreported.
Now, Ryan Jackson said that's the Heinrich's triangle or the accident triangle or Bird's triangle.
Yeah, it's Heinrich or Heinz, something like that.
Yep.
Yeah.
Heinrich.
Yeah, the Heinrich maneuver.
Yeah, I know it's not. Okay. So from our discussion on Monday, we were talking about from a shock perspective, the severity. You have to understand the path that the current takes through the body, the amount of current that passes through the body, and then the amount of time. And we talked a little bit on Monday about the fact that GFCIs don't limit the amount of current that flows through your body. A lot of people think that a 4 to 6 milliamp, no matter what circuit I'm hooked up on, I'm only going to see 4 to 6 milliamps. But in reality, you could see amps. But the overcurrent device is going to limit the amount of time that that current's permitted to flow through the body. So
now, when you did GFCIs the other day, I wasn't able to tune in. Did you get into GFCIs that are listed as portable with open neutral protection?
We did. We had a discussion about how they're tested, and that we didn't go as deep. Nihad and I were talking afterwards that we're going to probably have to do another session because he wanted to go a little bit more deeper, and as did I, into some of that testing that recognizes the open neutral on the primary, which is why we check our extension cords and things of that nature because we have to be able to detect that. And there was another one too, I think a grounded neutral in different locations as well.
Yeah. Well, basically, if you go into Home Depot or Lowe's and you buy a standard GFCI receptacle, and you wire it up and you open the neutral, you can get current flow to ground through that receptacle till the cows come home. It'll never trip because the brain in that device only operates if it sees 120 volts. So a GFCI that is listed as portable, the older ones had a mechanical recloser on it. The new ones It's just a relay inside the device. So when you're buying those to use around the house, and in construction, for example, you can use a permanent receptacle, but you got to plug in it at the point of use. You have to plug in a GFCI device that is listed as portable. And what happens is, if you plug that in and the neutral's there, you don't get anything out of it. When you plug in these newer devices, if they see 120 volts, all right, meaning that both the ungrounded and grounded conductors are there, then it closes a relay and you get power to the female end of the cord. If you open the neutral or if you open the ungrounded conductor, you open both conductors. That's a device that's listed as portable.
Yep. And then Nihad pointed out in the chat that grounded neutral on the load side is another test. And I know, that's one of those things that we catch from a GFCI perspective. And a lot of AFCIs, arc fault circuit interrupters, get the bad rap because when they have ground fault put in them or a ground fault protection of equipment, we'll detect those downstream grounded neutrals because of the way we do the listing and whatnot. And that's typically what you'll find, like in a receptacle, they put that bare copper conductor on one side and they have the same side as the neutral, right? They don't put that on the right side. Yeah. And then you'll ground when you push that receptacle back in, or sometimes in can lights and things like that, nicking the neutral and causes a ground and neutral. So.
Yeah. And just we're nowhere near it, but they make great stocking stuffers. You can buy those for about $15 in Home Depot.
Yep.
And you give them so I would always have some of those and a few bottles of wine. And if somebody came in, I said, "Hey, look what I got for you: a bottle of wine and a portable GFCI."
Now, do you give them a choice? Do you say you can give either the bottle of wine or the portable GFCI?
No, they get both.
They get both.
We don't have a choice.
Okay. Not in your house.
Not in my house.
So then the magnitudes, the other discussion is how much current flows through the body when you're going to feel the tingling sensation. And we had a lot of discussion on Monday about where these numbers came from, Jim. I found some, and I think I shared that with you about the 1930s with what they were testing from a fence perspective. But why? Let me help me understand. Why is it so? Why do you think it's important for an electrical worker to understand these current levels and the physiological reaction? Why do we share this with people?
Well, one of the reasons is that, OSHA in 1926-21, and there's a requirement in the general industry standard, everybody has to be taught about the hazards in their workplace and the potential of damage or injury to health. So, they have to understand all of those things. But when you point out to the electrical worker that they can get to the let go threshold at 0.01 amp, they understand that's not a lot of current, and that if that flows through their body, all of their muscles are going to tense up and they're not going to be able to let go. So it's extremely important for them to understand this. And the data, Tom, you're right. It's very interesting when you chase these things down. I don't think you could do this today. I don't think that in 2020 we could say, all right, well, we're going to get 50 volunteers and we're going to run current flow through the body. We'll have a doctor standing there. But years ago they did it, and the key takeaway for me is that in all of these studies, it was all men, and women wouldn't subject themselves to this, which proves that women are smarter than men.
No, they did test women, but the thresholds are lower because you look at a guy and you say, "Hey, I want to see how long you can hold on to this." You know what they're going to do? It's going to be like a competition on how long they held on.
Well, no, part of the reason for that, Tom, is that, and there was resistance studies done.
Yes.
And men typically had a higher resistance because they had, drier skin on the hands. You get a bricklayer, and their hands are like leather. Mm-hmm. So somebody that's out working outside and they're working with their hands, they're going to have a rougher hand. They're not going to have that same lower resistivity that you would see with somebody that's not doing that type of work.
Yep, I gotcha. And then this does the relationship between the amount of current and it's I sort of like this because it shows you like from a circuit breaker, like a 20 amp circuit breaker, when that trips, and that all of this activity between respiration issues, difficulty breathing issues, fibrillation of your heart, all happens well before the circuit breaker actually will open. So
Absolutely.
I like that. I like that diagram, and then the path that it takes to the body. Now, you know, they show in here, Jim, the and I was going to talk about this a little bit on Monday as well, but I didn't really think about it until later. But you know, they show, and I know historically they show the heart on one side of the body. In reality, though, the heart is in the center of our body, right?
Yeah, yeah.
It,
I don't know, who made this
Yeah,
um,
and
drawing.
in cases, you know, they talk about. I think historically, that's what we always showed was the heart on the left side of the body. That's why, like Nihad pointed out, that years ago, electricians they would say put your left hand in your pocket, and you only have the right hand, so if you did have a problem. But in reality, that current flowing through your chest cavity is probably going to get your heart.
Yeah, yeah. And one of the reasons they told you to put one hand in your pocket is so that you didn't get it hand to hand.
Yeah, yeah.
That was one of the reasons.
They wanted the path through the body, and then this.
Yeah, it's the path, the magnitude, and the time.
Yeah.
They're the three things that are gonna determine the outcome of a shock incident.
Yeah, and this is your magnitude. This is what UL tells you the threshold needs to be. This is the threshold from a perspective of your heart going into fibrillation, and this is actually where your Class A GFCIs operate and function, which is much faster than where the UL, just because of the physical nature of the devices, and much faster than your heart going into defib. And then I threw this in there just to. I always every time I do an education around ground faults and shock protection. You know, I know people use terminology freely, and sometimes we'll say ground fault. Go give me I've heard GFCIs referenced as GFP, right? But there is a distinct difference between ground fault protection of equipment and then ground fault circuit interrupters in the National Electrical Code. And I just try to drive that home to raise the awareness that a GFCI is not a GFPE device, and GFPE is definitely not going to provide the same level of protection as a GFCI device.
Yeah,
So,
what was the term that they tried to use? Was it special purpose GFCIs, and they were going?
yeah, so that was the special purpose GFCI is a device, and we talked a little bit about that as well in our last and on Monday as well. They go at a higher level, but the whole drive around that is that you control the amount of voltage across the human body, and then if you can control that voltage potential via an assured equipment grounding path and all this other good stuff, then you know how much current would flow, and then you can provide some level of protection to keep the heart or from going into defib, or even try to keep it below that let go threshold. But there's a lot of other little aspects. That's why panel 2 said no to it, because there's a lot more to installing a device like that than like a standard GFCI.
Yeah, I think that, whenever we see CI, ALCI, AFCI, GFCI, we're talking about people protectors. And when you start to get above 4 to 6 milliamps, really what you have is low-level GFPE.
Excellent. All right. Now we got in. So I put this in. I think it was after the fact, Jim, about just electrically safe. You know, establishing an electrically safe. You know, you've corrected me. I don't know how many times where I'd said, work de-energized. And what's your typical response? You're telling me you have to establish an electrically safe work condition.
Well, that's not what I tell you. When you're going to do electrical work, I tell you to hire somebody. I tell you to hire a qualified person. But what's on the screen here, and I'm glad you threw this in there. Article 120 gets into electrically safe work conditions. And when we are up front and we're doing our risk assessment in 110.1H and NFPA 70E, when we take a look at the hierarchy of risk control, list item number 1 is elimination. And the only way we can eliminate an electrical hazard from electrical equipment is to create an electrically safe work condition. And what you have here in 130.2 is this is where the requirement for when you need to create an electrically safe work condition exists. And then in 130.2a, you get into energized work. So there you get into your, I call them your justification thresholds, infeasibility, additional hazards, or increased risk, less than 50 volts, and normal operation. But taking a look at this text, it's going to tell you that all electrical conductors and circuit parts that are at 50 volts or equal to or greater than 50 volts have to be put in an electrically safe work condition before you get within the limited approach boundary. And the limited approach boundary from 50 volts to 750 volts AC is 3'6". So if we've got energized parts, and we're going to get closer than 3'6", then the general rule requires an electrically safe work condition. The second threshold to establish is where an employee is interacting with equipment where conductors or circuit parts are not exposed, but an increased likelihood of injury from an exposure to an arc flash hazard exists. And the best example of that would be, I'm going to be opening and then racking out a 4,000 amp low voltage power circuit breaker. So I'm interacting with the equipment in a manner that increases the likelihood of an arc flash. And what we do up front in the definition of arc flash hazard is we provide two informational notes. Informational note number one very clearly lays out when you have an arc flash hazard, which is when you have exposed energized conductors or circuit parts, which is easy, or you're interacting in a manner that increases the likelihood. And the second informational note sends you to the likelihood table. It sends you to table 130.5c, and we tell you, we list all of the tasks where you would be interacting with equipment in a manner that increases that likelihood.
Absolutely. All right, cool. And then we get into the hierarchy of risk control, right?
Yeah, and the hierarchy of risk control methods come from an ANSI document. They come from ANSI Z10. And we deleted in the 2021 edition. You won't see any of those informational notes there anymore. They're gone. They're gone because there was a misconception that since we referenced ANSI Z10, that we had to use our risk control methods the way ANSI Z10 solved them. And ANSI Z10 solved them as elimination, complete elimination, 24/7, 365. So how do you eliminate a source of voltage in an electrical distribution system 24/7, 365? You cannot. It's impossible. So we've got informational notes now to explain that elimination is the creation of an electrically safe work condition. But we'll get there in a little bit. You have to remember that the act of creating an electrically safe work condition is actually energized work. So that's elimination. Substitution is very easy, but it lends itself well to design. Instead of installing 277 volt control circuits, let's install 24 volts. Yep. Engineering controls can be applied at almost any time, but they lend themselves well to design. We could have an energy reduction maintenance switch. We could guard. We could blanket. Awareness is labeling. Administrative controls is training and other things. And the last resort is PPE. But keep in mind, many people that apply the hierarchy of risk controls think they need to just choose one. In many cases, you're using more than one.
Yeah.
So we could be using three. We're going to utilize an energy reduction maintenance switch. We're using 4 with awareness. We're using 5 because we've got training, and we're using 6 because we've got PPE. So don't think that when you're applying the hierarchy of risk control methods that you're limited to one.
Right. So a lot of the stuff that we'll be talking about are up in this higher region, which the more you do in one, the less likelihood, at least in my mind, of having an event where you're going to be relying on your PPE because that's your last level of defense, right?
Absolutely. So elimination. And I see problems where we're installing temporary on a job. and we don't think it out. All right, so let's eliminate the need to ever get into or be exposed to service conductors. Let's install a 400 amp fusible disconnect, and then we've got a feeder supplying a main lug only panel board. But let's not put a 400 amp main in that panel board, because when we take the dead front off of a panel board and we've already opened that device, this is a question that comes up all the time, and the line side of the overcurrent protective device is still energized. People will say, well, Jim, look, we opened the main, we de-energized all the bus and everything, we don't need to wear PPE. The answer is you do need to wear PPE. You've got exposed energized conductors or circuit parts on the line side. So there's a shock hazard, there's a restricted approach boundary, there's a limited approach boundary. You've got an arc flash hazard, so there's an arc flash boundary. But let's take a look at what they did, Tom. When they opened that main, they de-energized all the bus and the load side of all those devices. Mm-hmm. So they significantly reduced the likelihood of an occurrence, but they didn't eliminate it.
Interesting. And I think this is this one here. Oh, so this is out of 70E with the examples.
Yeah, this is coming from Annex F, and in Annex F we get into risk control, and in Annex F we reference the hierarchy of risk controls, and we give you examples in Annex F. There's a significant amount of great information in the annexes, and here in Table F3, elimination is conductors that are placed into a state that we call an electrically safe work condition. Substitution, instead of 120 volt control, use 24. Engineering, you could guard energized electrical conductors. Awareness, it would be signs. Administrative controls is procedures, job planning tools, training, and much, much more. And then PPE is just that, shock and arc flash PPE.
Yeah, so I broke down, we broke down our discussion today into maybe five, I think 6 categories: barriers, disconnects, working space, labeling, grounding and bonding, and maintenance. And all of those can be looked at inside of this from a risk control perspective, higher up in that hierarchy of control.
Absolutely, it would all be in the top 3.
Yeah, all be in the top 3. Okay, so establishing.
This is the definition of an electrically safe work condition, and the key here is for everybody to understand that an electrically safe work condition is a state. We have to create that state, and then we have to maintain that state. As long as we do that, we have an electrically safe work condition. So that's where we've got an energized motor control center, switchboard, or panel board. But what we do is that electrical conductor or circuit part is disconnected from energized parts, is locked and tagged in accordance with established standards, and those established standards are your employer's written lockout, tagout procedures. Now, 1910-333B2 requires those written procedures to be prescriptive, and then they should be tied to the steps to verify an electrically safe work condition in NFPA 70E 120.5. Then we test to verify the absence of voltage. 70E says you have to test your test instrument first, verify, test your test instrument again. And if necessary, then we temporarily ground for personnel protection. But the only time we do that is if we believe that there's potential for induction or we're not in complete control.
Wait, when you believe there's say that one more time. What are the two things you just noticed?
Induced voltages. If we believe there's a potential for induced voltages,
gotcha.
Then we're going to have to apply temporary grounds. And it's very interesting when you go into your likelihood table, you'll see that the application of temporary protective grounding after verification of absence of voltage is considered to be interacting with the equipment in a manner that increases the likelihood of an arc flash. So you have to have all your PPE on to perform that task. And the reason is that the committee looks at it and says, if you made a determination that you need temporary protective grounding, then we need that individual wearing all their PPE until it's applied.
Yeah. Yep. 120.2 gets into your lockout and tagout. You have complex and simple, right?
Yeah, well, this, and the only thing, I didn't think we'd have time to get into to those, but this is included here because in 120.2A general, this is where we tell you that safe work practices, which means shock risk assessment, arc flash risk assessment, identify the PPE, okay? So all of that, we have to do that in accordance with Article 130 until such time that electrical conductors and circuit parts are in an electrically safe work condition. So it doesn't matter what if we're going to de-energize and create an electrically safe work condition in a panel board or a switchboard or a motor control center, we need to do shock risk assessment and an arc flash risk assessment. We need to determine all the PPE we need if we were going into that equipment in an energized state, and we need to be wearing that while we verify absence of voltage. After we verify absence of voltage, then, and it is, we established, in accordance with 70E, we established an electrically safe work condition, and we maintain that state, then we don't need PPE. Gotcha.
And this one here just shows that hierarchy. Everybody shows it as a triangle, and shows that PPE is your last resort. And this gives, like you gave one of the examples of for replacement or substitution. Replace 120 volt circuits with 24 volt control because 50 volts is that limit. Anything below 50 and below, you don't have a shock hazard associated because you don't have enough voltage, right? And then,
yeah, well, and I mean, we do, when, in 130.2A4, we do, or A3, we do mention there that where you're below 50 volts, you do have to do an assessment, okay? And you have to determine the overcurrent protection. So it could be 48 volts, the overcurrent protection, and the available fault current. And you have to make a determination that there is no exposure to arc flash. So, and the best example there is you take a car battery. Everybody's done that, and everybody's made a mistake, and you created an arc, and your clothes were on fire, and you had third-degree burns. No, none of that happened, but you were more careful after that. But let's take 4 of those batteries, put them in series. We have 48 volts. And then let's take 200 sets of those and put them in parallel. We still have 48 volts. And who wants to put a wrench across that?
Right. Yeah, that's true.
So what we're telling you there is you need to make that assessment. You need to make that determination.
Excellent. Excellent. Then you have so we have the boundary. So you have your limited approach, and actually I have a diagram on that one.
Yeah, and the key is that the boundaries are the triggers. So, the limited approach boundary is going to be, at a limit where there is a shock hazard. So, that's going to start at 120, or limited approach start at 50 and go to 750 AC. It'll be 3'6". And we're saying there that there is a shock hazard because you could lean into it, something you could holding could go into it. With restricted approach, all right, that's a distance where there's an increased likelihood of electric shock due to arc over combined with inadvertent movement. And that starts at 121 volts and goes to 750 volts. And that's 1 foot. And that's a trigger. So the limited approach boundary, the trigger there is only qualified persons cross that boundary. Restricted approach boundary, okay, only, if we have to cross that boundary, we have to be wearing rubber insulating gloves and leather protectors. If we're using a tool, it has to be insulated inside the restricted approach boundary.
Right. Now, when they get to the limited approach boundary, they put 2 different distances. One has exposed movable conductors and the other is exposed fixed circuit parts. So the movable ones are like your outside lines and things like that, anything that would be not secured down that could be exposed, energized parts that might sway with the wind or whatever, not right?
That's right. Yeah, the very first column, you'll see a little superscript C at the end of it, and then when you go down to the bottom, just like you said, Tom, we say that's overhead conductors pole to pole, and
yep.
we're just not doing that work, so we're always using the third column.
Excellent. All right, so this is going to be our discussion moving forward. So we did a lot of discussion about the risk and risk analysis, We dug into 70E a little bit there, not quite a lot, but enough to give us a good foundation. Now we're going to be talking barriers, disconnects, not in this order though. Barriers, disconnects, working space, labeling, grounding, bonding, and maintenance. So these are I think the big categories that if you're from a National Electrical Code perspective, from a 70B and a 70E perspective, there are requirements and guidelines that help help put these things in place. And you know what, Jim? When we talk about code adoption, everybody, a lot of people will try to delay code adoption. I know you've fought the battle just like I have and others. A lot of people lose sight of the fact that there are requirements in the National Electrical Code that might not be a product installation requirement. From a you need to install this you need to install this device in an application, whether it be a GFCI or an AFCI or something like that, or a specific type of fixture. There are a lot of requirements in the code that are that provide working space and barrier requirements, and then maybe require a disconnect for the electrical worker. And when you don't adopt the code, you're missing out on a lot of those things, as well as from a safety perspective. So I think it's huge.
You can take a look at the list that you have there, Tom, and the requirements for barriers. Essentially, the last couple of cycles have significantly increased. Disconnects, with 110.25, you're going back a few cycles. Working space, it's been there in labeling, but that's really all about protecting people.
Yeah.
That's what that's. I mean, grounding and bonding does as well, but it's also going to protect the building and maintenance as well. And maintenance is a key piece when you're doing your risk assessments. So it's all of the topics that you picked here, are tied directly to shock risk assessment and preventing that.
All right. So the first level that we're going to talk about are barriers, and I see Don Ganir has had a question, and it directly relates to these requirements. And his question is: do the barriers required on the line side of service equipment, which is what I'm showing on the screen here, eliminate the exposure to energized parts in service equipment?
And that's a really good question. Why can't I see the chat box? What do you got me blocked out here or something?
No, you know what? I it's on YouTube, so you shouldn't be streaming the YouTube. Here, let me.
Oh, all right. No, yeah. I don't see it. Okay, that is a really, really good question, and that's a determination made by the employer. And people have asked me that. As a matter of fact, Tom, when we did that 70E thing, there was multiple questions, and somebody singled it out and said, "This is for Jim," and it was that exact question. And the answer to that is that determination is made by the employer. When we have, for example, let's go into a manhole. All right, we're going to go into a manhole, and it's a confined space right off the bat. But is it a permit required confined space? Well, the first hazard we're going to look at is atmosphere, but that's good. So we've got energized conductors in there, and everybody says, "Oh boy, that's a permit required confined space." Maybe. So we go down there, and what we have is neatly racked 480-volt feeders that we installed a few months ago. Well, the fact that they're in the manhole and they're insulated, I mean, they are not necessarily a hazard. We're going to take a look at the task that we're going to perform. So the same holds true for barriers. Now, these barriers aren't all created equal. I have seen some, and I'm sure Don Ganir has seen them as well. I have seen some that are extremely robust and do a fantastic job of actually eliminating any potential. And when I say any potential, the most likely would be like a metal fish tape, which we shouldn't be using in this situation anyway. If we needed a fish tape, it should be non-conductive. But others aren't so tight, because the UL standard for inadvertent protection wouldn't necessarily require what we see on the screen. This manufacturer went a step above. So the bottom line is the individual, the employer is going to have to make that determination. You're going to have to dress when you open that equipment because you don't know if there's a barrier there. And then you're going to have to make a determination if there are exposed energized conductors or circuit parts.
Yeah. This is an example. I was doing an educational program, and outside of the building we were doing break, there was an enclosure, and somebody lifted up that hood, and there was exposed energized conductors. Now it's low voltage, it's a 20. I don't know what amp that is, but it's 240 volt. It's not a big 3-phase system or anything like that. But like you say, shock from a voltage perspective, that's just as hazardous. And you don't know it's like a box of chocolates. You never know what you're going to get until you open it up.
Were you wearing your PPE?
Yeah, I was. Yeah.
Okay. Just checking.
I let somebody else open it.
And what was the justification?
What?
What was the justification for exposing yourself to energized parts?
Oh, an educational event. See, that's why we shocked all those people years ago. So
yeah, I look forward to your public input.
Absolutely. Wait, Dawn. I think Dawn had another question. Let's go back to that. Barriers required on the line side of the service equipment. They don't eliminate the exposure, but they reduce the likelihood of coming in contact with something exposed, right?
Oh, significantly. All of them will do that.
Yeah.
All of them will do that. But it's my personal opinion that some of them that I've seen are so robust that they eliminate that potential.
Yeah, I agree.
Yeah.
All right. And then he says, and I think we're going to get this, but might as well just take the question now. Can you comment on the use of non-contact voltage indicators to verify absence of voltage on 600 volt and less systems?
They are excellent tools. They're excellent tools, but all they are is indicators. That's all they are. They're just indicators. And those devices can be fooled. All right. They can be fooled into not seeing potential, and they can be fooled into thinking that there is potential. So it's a really good indicator. But when you're verifying absence of voltage, you have to use a test instrument that makes contact. That's a requirement in NFPA 70E. You have to use a test instrument that makes contact. Now, when you get into that in 120.5, we're going to tell you that when you go over 1,000 volts, you can use a non-contact device. You're over 1,000 volts, you can use a non-contact device. And there's an exception that permits permanently mounted absence of voltage detectors, and they're listed for that purpose. And we're beginning to see a lot of those spec'd out in industrial type facilities.
Yeah. They I remember when at the Eastern section, I won one of those 120 volt proximity voltage sensors, right? And what was the first thing you did? You remember that? You tried to take it off me. You tried.
Oh yeah, because you'll get killed.
But you know what you taught me there was, and I looked at the instructions. They're pretty particular with regard to the shoes you're wearing and how you're supposed to use those, because you've got to ground yourself when you're using it, else you can get false positives, I believe.
Yes, you can. There's a number of potential modes that you can get into where they will fail. And another significant problem is people using those on type NM cable. And homeowners make this mistake all the time, as well as electricians. And you're in an area where it's damp, and another place that we see it is temporary. We've got open splices all throughout this job, and we're using type NM cable. Type NM cable is an outer non-metallic jacket, and then there's insulated conductors. So, for example, 12-2, there's 2 insulated conductors, a bare equipment grounding conductor, paper wrapped over it. Well, what happens is the moisture that's inside the NM cable, and it wicks its way several feet into the cable, and it's in intimate contact with the equipment grounding conductor, so it acts as a shield. So you'll take your non-contact tester, hold it on both sides of the type NM cable, you think it's de-energized. But if you take it to where the conductor is stripped, boy, it starts beeping and lighting up. And that's a function of training. Anybody that is going to give those out to employees has to train them on the limitations of that device.
That's a good point. You know, I did a 70E class one time for some people, and I asked them, why are you here? It was a company. I said, why are we here talking about this? And they said, well, our manager bought us this personal protective equipment, and we've got to figure out how to use it. So I told them, I said, go get it. They had it in the car. So they brought it out, and we laid it on the table, and they had coveralls. And so I asked them, I said, what do you wear under the coveralls? And they were like, well, what I'm wearing right now, which was all polyester and, you know, dress shirts and stuff like that, which they had no clue that you just can't wear that stuff underneath that, because, you know, the heat will melt that, even though it's underneath the personal protective equipment, it's going to melt it to your body. So, you know, it's a factor of education and training. Now, Ardo, you know, when I looked through the code on barriers, I learned that very quickly that they use the term barriers in the NEC, but they also use this term guarded a lot. And in many different areas, there's provisions to require guarding of energized parts. And so I threw in the definition from Article 100 of I'm using the 2020 code as a reference. And again, it says, you know, to remove the likelihood of approach or contact by persons or objects to a point of danger. So there are many different areas that would speak to guarding an area. And 70E talks about providing barriers and you know, carving out your workspace. So you establish your what do they call that? You have your limited approach boundaries and your arc flash boundaries, etc. And you should have. Now, let me ask you, Jim, if you were going to work, if you have on job sites that you've been to, do they actually physically delineate where the arc flash boundary is and where the restricted approach boundary is, or is that just something that they know?
Well, when you're doing an arc flash risk assessment, you're either going to be using the tables or you're going to be using you know, you have labeled equipment, which means an incident energy analysis was performed. So if we can look at the equipment, we're going to see the voltage. And it's a function of training that we're going to look at it and understand that I got a limited approach boundary of 3'6". I've got a restricted approach boundary of 1 foot. And then on that label is going to be my arc flash boundary. If I'm using the tables, I'm going to get my arc flash boundary from the tables. And electrical workers aren't going to take a rule and mark 3'6", and then if the arc flash boundary is 2 feet, mark that. They're going to know where that is. What they're going to do is they're going to dress outside that boundaries, and they'll dress outside the furthest boundary because they intend to get inside the restricted approach boundary. And as long as they're trained properly, they understand that they need those rubber insulating gloves and leather protectors on before they cross the arc flash boundary, because those gloves don't just protect them from shock, they protect them from arc flash.
Yeah. Yep. And so this is out of huh?
Go ahead.
I was going to say, I grabbed a couple definitions out of 70E. One was barricade, talking about physical construction, and then barriers. So there's some definitions in 70E and in 70, and they pretty much align with each other.
Yeah, well, and we tightened those up significantly for 2021.
Yep. I didn't mean to hit that other one. So 110.27, guarding of live parts.
Can you go back to that again real quick?
No.
No. Well, I just want to see what kind of tape it is.
That's painter's tape.
I think, well, everybody wants to see what kind of tape it is. Just do it real quick.
That was a mistake.
Just go back real quick.
I did.
There it is there. All right, it was just enough time for me to do a screen.
Oh! See, now you know what's going to happen. That is going to be in some PowerPoint somewhere, and I knew I shouldn't have put it in there. All right. So 110.27 talks about guarding of live parts. And what I like about this picture too is it has that key up there, which we know based upon readily accessible new changes in the definition, recognize that a key is not a tool. So I use that slide deck in that discussion. But there's a lot of labels on this. I think that raise awareness from a safety perspective, whether it's suitable for use of service equipment, and different aspects of the listing requirements and things like that. Adding distance. What do you think about this, Jim? Adding a little distance to the project, is that kosher?
Well, that switchgear lineup comes with a flying carpet. So it's a switchboard. It comes with a flying carpet. So when you need to work on it, you just get on the carpet and head on up.
Yeah, I don't think I'd want to.
That's like I've seen those pictures before, and it's beyond me that somebody inspected that, because where's your working space? I mean, what do you do? Get in a scissors lift?
I know. I mean, you need a platform somewhere out here for the worker.
It's crazy.
It is absolutely crazy. But you know what? I
If
say
there
you
was a
can't make this
platform on
stuff
it and a
up.
ladder, no, you can't make that up.
Yeah. So in 23062, it talks about enclosed and guarded. You have, energized parts have to be enclosed so they not be exposed to accidental contact. Guarded, energized parts that are not enclosed shall be installed in switchboard, panel board, etc. And they have reference for other areas in the NEC that talks about providing ceilings and things of that nature. And then barriers. Service equipment should no uninsulated, ungrounded service bus bar or service terminals exposed to inadvertent terminations, right?
Yep, and in C, I mean, did you get that far? Down in C, that was a significant revision in the 2020, because now we finally got it right. Now we're addressing all service equipment, and those barriers.
That's right.
All we say is inadvertent contact. So there's a lot of different ways to get that done. Some of them are flimsy, some of them are robust and substantial. But prior to 2020, in 2017, it's just panel boards, switchboards, and switchgear.
Right, and then we added the exception in 408.3, I think it was, in the 17 code. They added the exception for the 6 disconnect rule. But they said you have to have barriers on panel boards, switchboards, and switchgears. And then in the 20 version, they expanded the barrier requirements to all service equipment in 230.62C, which
and we took it out of 408.
And you took it out of 408.3, and then that raised the awareness that the 6 disconnect rule has had an issue that we had to address, and then we addressed that in 230, was at 71, right?
230.70A1, I think it is. Oh no, A1 is location. It's in 230.70. Let me get a look.
71B.
Yeah, 71B. That's it.
Yep. And then we gave options for either separate enclosures, etc. So, and all of that was really around. Although here it is, right here. So it was my next slide. 230.71B says 2 to 6 service disconnecting means, and they gave us. We didn't say you can't do it, but we said if you are going to do up to 6 disconnecting means, you got 4 options to do that.
Yeah, and I'm on this committee, and I knew that all we needed was list item 1. Separate enclosures with the main service disconnecting means in each enclosure, because when you get down into list item 4, you're in switchgear. Switchgear is compartmentalized. It's compartmentalized, so you could have 6 in a section of switchgear. But list item 2, we added panel boards in with a main disconnect in each, because that was the most popular way of doing 6 disconnects. And then we got into switchboards where there's only 1 disconnect in each vertical section, and there's barriers. And 6 disconnects in switchgear is easy because it's compartmentalized. Metering centers, we're working on that. We've got some problems there.
Yeah, that's this here. That's your, and the big issue is trying to compartmentalize these breakers and meters. And there's no solution on the market right now. So when people ask me, how do I handle this? I tell them you need to put a disconnect in front of it.
Yeah.
That's the only solution you have. And then you have this type of situation where you don't have a disconnect on the outside. And we made a change in 230.85, right, for an emergency disconnect. So an installation like this, where the main service panel's on the inside, is
As long as it's a 1 and 2 family dwelling.
yeah, that's right. This is not a 1 and 2 family dwelling. That's true. But if this was, then I would need a disconnect here, which could be a meter disconnect. And that would be permitted. Or
Yeah.
I could put a disconnect there.
Right, and the easiest way to do it is to just buy a meter housing that has a side compartment with a 102 pole or 202 pole, and you're done.
Yeah, good point. Yep. And then that's just another meter center that has that same issue. And there's another one. So I just threw some images of now, and then you have one like this. Now this, the main breaker, I believe this center cavity has that main overcurrent device.
Yeah, that's going to be a main in there.
Yep. And then you would have to barrier off the line side based upon the barrier requirements. And then this would meet the emergency disconnect. This would have to be labeled as an emergency disconnect.
They might have some workspace issues on that right side there.
Oh, yeah, because of the transformer.
Mm-hmm.
Yep. And another thing about barriers, so distance, and we see in Article 230 in Part 2 talks about overhead service conductors, and you'll find various requirements in 230, especially in Part 2, that talks about requirements for how far away it needs to be from the building, how high it needs to be. Those need to be off of the street, etc. And all that's about shock, right?
Yeah, we don't want people reaching out a window or a fire escape, et cetera, and hanging their laundry on service entrance conductors.
Now, do you hang your laundry outside the window?
No,
Okay.
no, I don't have any. You know, I have a lateral.
Oh, you don't wash clothes either, right? So you wear the same clothes
No.
over and over.
Hey, you get all the mileage you can.
Turn them inside out. That's what I always say. Now, so I put this one in there for 230 as well, 230.75. Or again, I'm not hitting everything. And, we tried to cherry pick this. So 230.75 is your disconnection of your grounded conductor, because the IEEE Electrical Safety Workshop, we did some of our Eaton guys did a presentation and did a paper on, how dangerous that that grounded conductor can be. And you can get hung up on that. I think didn't you have a personal experience on that one?
Well, yeah,
Was it that?
I investigated a fatality. In my time as safety coordinator, I investigated 3 fatalities within our membership. And one was a 26-year-old that got hung up on a neutral. And it was a very, very sad situation. But we'll get there, and we'll talk a little bit about that's the reason in a multi-wire branch circuit that we require a simultaneous means of disconnect today. They were in an older building replacing some lighting, and they shut the circuit off they were working on. He was an apprentice. He didn't fully understand multi-wire branch circuits, and he got hung up on the neutral. One of the reasons for this requirement is so that we can remove that neutral link when we're doing GFCI testing.
Ah, good point. Yeah, that's right. You got to remove that to do that testing. And there's the 230.85, which we sort of briefly talked about with the options. So this started out as the firefighter disconnect last cycle, remember? And
yeah, and that's really what this is all about. This is to give the firefighters, first responders, the capability to remove power from the building before they put water on the building or go in to the building. And they've tried to do it in the past, and they've pulled meters, and there's been people injured. And then when there isn't a meter, and they're overhead, they try to go up there with bolt cutters.
Yeah.
And there's been multiple incidents with firemen hurt. There's been situations where firemen, there was energized conductors in the building. They had to get out, and then they lost the building.
Yeah. Yeah. And then, so they gave us three options, and I put my artistic, creative work together, and I did my own drawings. There's other people that like Keith Laughlin and crew that invest a lot of money in graphics, and I realized all I needed was my pen.
Yeah, you went to the Bar Napkin School of Art.
A bar napkin School of Art. So
Yeah.
so the first option is a service disconnecting means, which could be an outside panel board, right?
Yeah, some areas of the country, I know, for example, in the Phoenix area, driving around, you saw all of your service equipment outside, so they don't need to do anything. It's already done.
Yeah.
They just need to make sure it's labeled properly.
Yeah. So if you have your outside service, you would have to label that service though with emergency disconnect, service disconnect.
Yeah, because it's actually two things. It's your service disconnect, and the firemen can look at it and they know that when they open that, they remove the service to the building.
Yep. And then
we've got requirements for optional standby systems. If you've got an optional standby system, you're going to have to put a sign right next to the emergency disconnect. So now I'm the fireman. I get there, I open that service, but I know that I've got an optional standby system, which could start when I open the service, but it tells me where it is so that I can go kill the prime mover.
That's right. So there's also I think batteries and generators both have requirements for that. Energy storage systems have a requirement for a disconnect, and then on the PV side of the world, that has the rapid shutdown, which covers all this. So there's nothing that was needed in the PV world.
Yeah, and the only significant difference there is, we require a line disconnect here, and we require the capability to shut down the generator. But with an energy storage system, you can actually have a shunt trip.
Right. Now, the second option is a meter disconnect, and that you would typically see on the primary of the meter, because that would be for, sometimes utilities require that. Some utilities require a disconnect up there.
Yeah, and if that's not a utility requirement, it's not likely the installer is going to go with that option because it's going to be expensive.
That's exactly right. Yep. And then now this last option, I would love for you to talk to, I still struggle with this one, in that says another listed disconnecting switch. And Don Gannier, or I think it was Ryan Jackson, asked that, the fact that I have an overcurrent protected device, it's the first piece of equipment on the secondary of that meter. It's not the service equipment. What would that be?
Yeah, CMP 10 had a lengthy discussion here. And we know that list item number 1, if you're putting it outside, it's easy. It's done. It's like Prego. It's in there, right? List item number 2, a meter disconnect, isn't a really good option. This is the most cost-effective, feasible option that's out there. And the reason it's written the way that it is, there's multiple reasons. Anybody that's involved in COJA standards, anybody that's been involved in the development and teaching COJA standards, it's like baseball and apple pie. That first disconnect and overcurrent protection, that is your service disconnecting means, and everything downstream is a feeder or a branch circuit. Well, in order to make this feasible, we're going to permit you to have a listed disconnect or switch or circuit breaker on the supply side of each service disconnect, as long as it's suitable for use as service equipment. And the most popular way to get that done is going to be a meter housing with a 2-pole 100, a 2-pole 200, etc. That's the most feasible way to get it done. Now, if we told you that had to be service equipment, now you need to get the grounding electrode into that enclosure, and you can't take SE cable into the home. You need to take SER. And one of the reasons that we went down this road and said, look, all right, we realize it's a circuit. It doesn't need to be a circuit breaker. It could just be a molded case switch,
Yeah.
which is probably where manufacturers are going to end up going. They're going to put a molded case switch in there because it's cheaper. But if it's got, a level of overcurrent protection in it, all the better. But we didn't want it to be the service disconnect because we didn't want to require you to take a grounding electrode conductor in there, and we didn't want to require you to take SER into the building. That would also impact service upgrades. Where you've got a service upgrade would be a little bit different if we allow you in a service upgrade to not call this disconnect your service disconnect, but call the main in your panel board. As soon as you land in that panel board or load center, then in there you can combine your grounded conductors and your equipment grounding conductors. So there was a lot of thought that went into this. And when you really take it apart and you say, what's going to be required if we don't do this, then you lay that out. Then you take a look at both methods and you say, okay, what's the net benefit? There is none. There's no net benefit to mandating that be considered as service equipment.
Yeah, and so you would have to bond the enclosure, obviously.
The enclosure is going to be bonded because the grounded conductor in your meter is going to be bonded to the enclosure. That's going to be done. But you're going to need to get a grounding electrode conductor in there, and then you're going to need SER. You can't use SE. You can't use two insulated conductors, and the concentric. If you're going to consider that to be service entrance equipment, you're going to need 3 insulated conductors, and then the concentric can be your equipment grounding conductor. But we went through all of that, and this is the most cost-effective way to do it. And if we force you to make all of these service equipment, there's no net benefit. In fact, if we make you make this service equipment, you're going to buy main lug only panel boards.
Right. Yeah, that's true. So Bruce says when using the utility disconnect ahead of the meter, that's your meter disconnect. He says, how do you get around the NEC requirement stating that service entrance conductors shall not be broken? That's not a service entrance conductor on the primary of that meter, is it?
Well, it would be. It would be because what ends up happening in a dwelling unit, the way you have it drawn, there's going to be overhead conductors from the utility, and there'll be a drop. That's a service drop.
That's right.
And then we've got our service point, okay? And that's where we're going to put, for example, a service head and SE cable coming down. But I don't know of the utility, I don't think would be very happy if you put a disconnect in front of their cash register.
No.
I don't think they're going to, but the utilities that do require cold sequencing, the meter disconnect switch is inside the enclosure with the meter.
Yeah.
And they typically require that so that they can replace the meter in a de-energized state.
Yep. Does 70E require a disconnect in front of a 480 volt meter? Do you know?
No. NFPA 70E is a work practices standard.
That's right.
It can't get into installation criteria.
That's right. It's outside of its purview. Okay. And then Ryan is noting that there's no requirement that a service conductor be unbroken. 230.42 tells us how to break them. So. Exactly.
I mean, we've got requirements for a continuous grounding electrode conductor, and it's got to be spliced. I mean, you certainly can't use a split bulb, but not so for service entrance conductors.
Gotcha. Good dialogue. All right. So that was good. And then I went back up to 404.5 timing switches and flashers. There's dialogue in there about requiring barriers. I believe down here on the bottom, if I'm not mistaken, permitted without barriers provided they are. Yeah. So this is just providing some more, again, barriers to prevent operator exposure. So it's all about ensuring nobody comes in contact and reducing the likelihood of shock. 404.6. Bolted pressure contact switches shall have barriers that prevent inadvertent contact with energized blades. Single throw knife switches, etc. So you'll see always on those disconnects and whatnot, there's always that plastic cover that is supposed to help prevent coming in contact with energized parts.
And those plastic covers do a poor job of preventing inadvertent contact.
Yeah, and probably primarily because of all the space that's around there. It's not an IP what is that, IP2 or IP7 or whatever that standard is. Those aren't like finger safe solutions.
Yeah, I'm not familiar with the numbers there.
Yeah, so unless they're installed in a closure. So, and then in 430.97, I put some notes in here. Barriers shall be in place in service entrance motor control centers. So this, we talked about this. Where were we? We were just on a call.
Yeah, we were working on right now. So everybody knows we're actually working on an exception to 23071B, because in at least one area of the country where they've adopted the 2020, there's permits that have been filed, and an owner installed a meter center with 6 meters and the potential for 6 disconnects, and he only had 3 tenants, but now he just got another tenant, and we've got I don't think it was a metering center. No, it was a panel board, right, Tom? It was a panel board.
Yep.
So he installed a panel board with three service disconnects, but he's got provisions for 3 more, and now he got another tenant. And if you go by the literal wording into 2020, he can't do that. So we're actually working on an exception that would identify those existing installations that were installed with provisions to add up to 6 devices. That was Monday, wasn't it?
I think it was Monday. Yeah, I can't remember what day it was, but I know because it popped. No, it was actually Wednesday, because it was yesterday, because it was after my motor control center presentation, or maybe it was Tuesday afternoon, and it was in my mind about MCCs, because the way this list goes, it puts the separate. It talks about the different types of equipment, right? But MCCs wasn't in there. But then, in fact, there's a barrier requirement in 430 for motor control centers that covers a motor control center for service entrance equipment.
Here's a good idea for 2 public inputs. Take it out of here and put it in 23062C.
Ah, good point. Very good point.
That's
all right.
2 public inputs.
What?
That's 2 public inputs for you.
Well, yeah, one to take it out and one to put it in. But what if the one that takes it out gets passed and one that puts it in doesn't get passed?
That's why there's a correlated committee.
That's why there's a correlated committee. All right. So I threw some images in on barriers, just to hold, because we're on the barrier discussion, right? So those are very useful. I would think they would be very useful.
Yeah. I mean, it would be a barrier between you and an exposed energized part.
Right.
It's insulated blankets.
Yep. And then I know the utility guys use a lot of those things.
Yeah, it's a different world there. Completely different world.
Yep. And then I like that picture there. It's not a barrier thing, but I think I took that picture down in Alabama. Then you got your gloves.
Hey, that's all they have. Yeah, they made it work.
That's right. Yeah, made it work. Your gloves are a last resort, right? And then other barriers might be where like these types of solutions where you have finger safe solutions that you install this industrial control panels. You install products like these in industrial control panels. And this is through the dead front, so you can change the fuse out and then be able to not be exposed to energized parts, and whatnot. So there's solutions on the market that people can specify that aren't required by the code, but add an additional level of protection.
And the way those cubes are made and listed, you can't pull the cube fuse out while the device is in the closed position.
Yeah, a lot of people miss. You know, this here is the it's just a UL98 switch, and the yellow thing here is your fuse. And what happens is there's a pin that goes through these leads whenever you hit whenever you turn this on, and you can't pull it out and you can't put it in while it's turned
No.
while this is on as well. So that's a really nice way from a lockout tagout perspective. You pull that fuse out, there's no way anybody can re-energize that circuit without that fuse in there.
And that's a good example when you get into the hierarchy of risk control, your engineering controls.
Yeah. Yep.
All I see on my screen now, it says error.
Yeah, it says due to low bandwidth, I just lost you. This happened once before to us, remember?
So you kicked me out? What do I got to do, sign back in?
No, hold on. I'm going to reshare my screen. I'm already sharing, so I don't think the bandwidth is on my side, bud. JD, you want to try dialing back in again?
Well, I'm not going to dial back in.
Yeah.
I'll leave this open and then just try to join it again.
That sounds good.
I think I just saw it. Where did I just see it? All right, keep going. I'll get in.
All right. So the next one we're talking about is disconnects. And I don't know why this says presenting or give control.
I can see it now. I can see it now.
All right. So the next. Oh boy.
That was me. I had to mute. I had to mute my computer.
All right. So the next area that we're going to be talking about is the disconnect, right? So this is.
So, are you in a submarine?
No. There you go. Can you still hear me? Can I still hear you?
I can hear you.
All right. I got two of you in here for some reason.
Yeah, it's because I got one with the phone and one I can see.
No, there you go. Oh, that's right. You had to dial in.
Right.
All right. So disconnects. So you have from a National Electrical Code perspective, we put a lot of requirements in that speak to providing lockable or disconnects for different types of loads, right? So that the electrical worker can turn off power while they're doing energized work. So in this case here, for example, there's the 110.25 talks about if there is a disconnect. Disconnecting means it's required to be lockable open elsewhere in the code. It shall be capable of being locked in the open position. And so whenever, it's, I think I might even have a picture of one of those that are lockable in the, oops, that's not what I wanted.
Yeah, the key is that the provisions for adding the lock have to remain in place with or without the lock installed. And there's a good example, and that was several cycles back. It was Mike Johnson and Donnie Cook and I. We were adding language, and there was just dozens of locations where, and in each location they were putting that language, and each committee did it a little bit different. So the correlated committee said, look, let's just build a new section in Article 110 to contain those requirements, and then wherever we have a requirement for a disconnecting means to be capable of being locked in the open position, they just refer to 110.25.
Okay, so when did about when was that again?
That was several cycles back, and we piecemealed those in over 2 cycles, and then the cycle after that, they built 110.25.
Okay. All right, and then I also put in here. So you talked about that, shared neutral or whatnot application. I was in a church one time, and they asked me to take a look because they wanted to add some things. And when I opened up the panel board, I saw something like this where they put a couple twins next to each other, and then they put this piece of copper wire through there, and the safety implications of that is that would be what is Tim Cernkos call that ungood, doesn't he?
Yeah, that's not an identified handle tie. That's a misapplication there.
Yeah, an extreme misapplication of an electrical wiring system. But that it's important to understand. You got to use the identified parts for handle ties, etc. And like you talked about the shared neutral application, where you want to make sure that you disconnect everything, and when you turn it into the off position, doesn't have to trip to the off position, but you want to make sure you disconnect all of those conductors.
Yeah, and I don't believe that there's a manufacturer out there that has an identified handle tie for split circuit breakers. So,
No,
everything's wrong there. Everything.
absolutely right.
And the one below it is a common trip, not a handle tie, because only you see the text only on one side. So that's a common trip. And it even says on that top one, common trip, you can see it.
Yeah, this one. Yeah, that's right. That says it says common trip right there. Yep.
Right, and the requirement for a multi-wire branch circuit isn't common trip.
That's right.
It's simultaneous disconnect.
Yeah, absolutely. And the whole purpose there is that when you do disconnect it, you take off both hots and disconnect and isolate that circuit.
That's right.
So every time I do that, it goes back to a previous slide, which I don't want to go to that one. Where's it at? I want to go to, hold on. I wanted to hit this one. This was another example of, having the provisions in place. Another example of having those provisions for locking in place. So when you remove the dead front, those lock provisions are still there. 210.8e talks about equipment requiring servicing. So 210.8 is your GFCIs, and we talked about this in the GFCI the online thing that I did. We expanded this, and we made some changes in 210.63 that better organized it, and we now have a provision that if you have equipment that has a requirement based on 210.63 where you have to have a receptacle outlet there for the electrical worker to plug into, that it has to be GFCI protected. And then we changed the equipment requiring servicing. We changed this. We reorganized it. We have the parent text here that gives you your overview, and then we have your A and B, which covers heating and air conditioning, your HVAC equipment, and then other equipment areas. This one here just talks about your outlet for HVAC. Required receptacle shall be located where it needs to be located. But I don't think we didn't change the intent of this, but we just added some rewording. The whole gist there is you want to make sure that receptacle is there for use when they power down the equipment for their testing and lights and whatever else that they might have, right?
Yeah, what you did there, you combined 210.63 and 64 into one section.
That's right. Yep.
Yeah.
Yep. And then you have your other electrical equipment, and we split other electrical equipment into two things: indoor service equipment, and then indoor equipment requiring dedicated equipment spaces. So, to your point, we combined those two areas.
Right.
Yep. Good point. All right. Then I went back to 430, so I bounced around a little bit. This is talking about disconnecting means. So back in 430, we have different requirements for disconnecting the motor, right?
Yeah, and that was many cycles ago. I remember just because later in your slide deck here, there's a requirement for a disconnect with inside of the motor. And that was a fight. That took a couple of cycles, but we finally got it.
Oh, you mean there was pushback on putting a disconnect for a motor?
Yeah, well, the pushback was, you can go upstream. Maybe that motor was fed from the motor control center in the basement, and you're on the second floor, and at that time, the pushback was, well, you can go lock it out there. Well, keep in mind, it was likely a circuit breaker, and we didn't even have a means to lock it in the open position. And there's always a look at cost, and there's many organizations that are going to look at a potential code change and say, you know what, that adds cost, and therefore we're against it. And the home builder's default position, whenever you add cost, they're against it. Now, a really big exception to that is that the disconnecting means, the emergency disconnecting means for 1 and 2 family dwelling units, the Home Builders Association wrote a letter and even came to the committee and spoke in support.
Oh.
And they wanted to do that because they wanted to take steps. They felt that based upon the data, the injuries, et cetera, to firefighters, they wanted to make sure that happened.
Interesting. Yeah, that's right. And I wonder if they'll support that in the state adoption, though. I'm hearing that they're pushing back on it at the state adoption.
And that's not, that's individual groups. That's splinter groups. So
okay.
and we see that all the time. We see in the code making process, panel members on a given committee support something at the table, and then within their state, they go the other way.
Yeah. That's unfortunate, but it happens, right?
It does. It happens.
Yep. And there's your motor disconnects, your controller disconnects. So all of these disconnects are there for when you're servicing or maintaining that rotating equipment. And we talked about the rapid shutdown and the fact that you need a disconnect for shutting down the system, and the rapid shutdown system, the way it works and operates. I believe there's different, you have to get it down to a certain voltage level, which is below the threshold. And I think there's like distance requirements, etc.
Yeah, it's primarily rooftop, anything on a building. And that's so that, the firemen can put the fire out. What it's going to do is it's going to build a boundary around the array, and we can't shut the array off completely. As long as the sun is shining, then the array is going to have an output.
Yeah, that's right. Yeah, and it doesn't even need to be the sun, right? It could be lights from a fire truck or whatnot.
Yep.
Yeah. And there's disconnect requirements. There's a lot of disconnect requirements in PV systems, alternative energy systems, and all the sources, generators, etc. And to isolate different parts of the system, and also in hazardous locations, there's an extensive amount of disconnect requirements. So what do you think about this one, Jim? This is a disconnect pretty high up on the wall for that AC unit. Is there an accessibility? Does that handle have to be within a certain distance or anything like that?
Well, 24024 is going to give you a height for a disconnecting means, but it's hard to tell exactly where that at. I mean, we see, for example, overhead garage door openers and condensing units that are mounted up high. And what that gives the installer the capability of doing is, when they get up, whether on a high reach or whatever, they can open that device and then they can verify the absence of which. They could most certainly do the same thing if it was located 4 feet off the floor. But this is a situation where in order to get into that equipment, they got to get into an elevated position anyway.
Right. That's true too. Yeah, because that equipment is, good point. Very good point. And then there's just an example of where when those provisions are there for a lock, that's there to receive the lockout tag out, and then I could lock that breaker and still take that panel off if I had to.
And that's a good picture because that lock would be acceptable in a lockout tagout procedure because it's identified as a lockout tagout lock. It's not the same lock that you're going to use on a Kang box or on a door, and you've got a tag, and the other side of that tag should have the name and contact information of the individual that applied the lock.
Ah, okay. Okay, cool. And then I like this one, even though I may not like the manufacturer there, but I do like the fact that those one-armed bandits that are there for disconnecting the immediate loads. And I always say, you pepper as many of these disconnects close to the loads that will facilitate someone pulling that handle down when they have to establish an electrically safe work condition. And there's that picture again. Love that one. And this one here is a motor operated shunt trip switch that basically you can open remotely without opening the door. So from again remotely, and you could have something actuated like I don't know. You can do ground fault protection. You can do some other method or whatever means that you want to automatically open this, as opposed to having somebody open it with their hand. So there's a lot of different options to get distance in and have it actuate based upon some other basis of condition. Or you could tie it to a door opening to the room and say, I'm going to kill this. If anybody enters this room for whatever reason, I'm going to kill the process that's going on in that room, or for whatever reason that you might have. I took this one on going out of the parking garage up at NTI, National Training Institute. Remember that?
Yep.
Got that. I said, I liked it because for a few different reasons. You have the equipment that it's disconnecting is right there, and it's a nice safety feature to have a disconnect close. And there's no necessarily a code requirement to put these types of switches where they're located.
Yeah, and I remember how you got in and out of there without paying, because I never knew that if you walked up and shut it off and turned it back on, that the gate went up for a minute.
You know what? You're not supposed to tell people.
Oh, all right.
Jeez. So then maintenance. So and I took that photo as well. Maintenance is another area of concern when it comes to electrical safety, and 70B, as in Bob, is our reference for that. And we travel at our own risk whenever we get into a maintenance perspective. Now, the National Electrical Code, Jim, does have some requirements for maintenance in Article 700. You're on panel 13. And
yeah.
700 and a few others. So, and I've had people tell me, the National Electrical Code, maintenance has no business being in the National Electrical Code. And I'm not sure.
That's not necessarily true. I think it's 700.3C.
Yep.
It used to read that you had to maintain your batteries in your unit equipment. So that's really what we were talking about. We were talking about emergency lighting that was using batteries, and the push to change that and say that you needed to maintain all of your emergency equipment actually came from a representative on the committee that represented the Healthcare Association. And the reason that they wanted to get that language in, we all knew that if you've got a new installation, 700.3C doesn't hold you to anything. But what happens is your state-run health commissions now are aware of that. And now they know that if you adopt the 2020 NEC, you are required, and I think that went in 17.
Yep.
You are required to maintain all of your emergency equipment, and they can force the hand of the healthcare facilities to do that because they're notorious for not maintaining their equipment. It's a healthcare facility, but they don't maintain their generators, they don't maintain their transfer switches, they don't maintain low voltage power circuit breakers, and it's a problem. Now, the picture that you have here, this is a really good example. You take a look at a piece of equipment like this, there's nothing normal about this equipment. So there could be no action with respect to NFPA 70E on 30.2A4 that would be considered normal. All right, because this equipment is in really, really bad shape.
You know what? And you brought up a good, when they're in the table that the 130.5C estimate of the likelihood of occurrence, because we talked about that at the very beginning, the likelihood of something happening. And when you look at the tasks, they'll say like reading a panel meter or performing infrared thermography. The second column says equipment condition, and it usually says any, normal, or abnormal. So anything you do on this equipment because of its condition of maintenance would be abnormal.
This is abnormal.
Yeah.
And a normal abnormal really only comes in where we take a look at opening or closing a switch, opening or closing a circuit breaker, and when we take a look at likelihood. All right.
Yep.
So what we do in table 130.5C is we take the provisions in 130.2A4 and we just run them down the road of likelihood. And we tell you if it's in abnormal condition or if it's not properly maintained, then there is a likelihood.
Yeah. And then in 590, they put a new requirement in that says for temporary power, when you're reusing overcurrent protective devices, that that you have to inspect them, and they use this term, no evidence of impending failure. And I think that was because when you're getting into temporary power, you'll get equipment that might, end up looking like this, although that's not temporary power, but just because of the fact that, you're going to take a piece of equipment like this and you're going to use it at this job site, then you're going to use it at the next job site, and you're going to keep reusing it over and over and over. And it can get to a point where, evidence of impending failure, which they added an informational note to tell us what that means, to give us some guidance on that. But that equipment can end up looking pretty ratty by the time, over the years.
Right. That language really came from 70E, and I actually helped write all of this. I sent these ideas in for 590.8 3 cycles in a row and got shot down by panel 3. So what I did was I had Donnie Cook send it in, and it made it through.
That's hilarious. That's good. Yeah, we don't care how something gets done as long as people step up.
As long as it gets done.
Yep.
And then I think if you go to the next slide is where you'll see the current limiting requirement.
The what? Oh yeah. So yeah. That's right. That was solidly grounded, not exceeding 1,000 volts face to face shall be current limiting.
Yeah, and that's a really good example of a safety-driven revision to the NEC. I can tell you that as safety coordinator from 2001 to 2018, I saw multiple arc flash incidents. I can tell you that I didn't see any at 208. Can you get 208 to sustain an arc? The answer is yes. You need significant amount of available fault current. You need a tighter arc gap and a smaller enclosure. But I can tell you at 480, 277, you will get arc duration on service equipment. I saw arc flash incidents on the load side of molded case circuit breakers, because that's what we're working with 98, 99% of the time, and the device would open. But when you get on the line side, it's not going to open. And even if you're on that load side in temporary power, if you've got a 400 amp molded case circuit breaker that has been on 6 different jobs, exposed to wide-ranging environments and dampness, and maybe it saw a fault at or near its interrupting rating, we don't know what's going to happen there. But if we have current limiting requirements, we're going to have current limiting fuses or current limiting circuit breaker. And if it's current limiting fuses and they open and we replace them, where is our level of protection?
Yeah.
Right back where we started.
Absolutely right. Yep. And
you're getting pretty close.
Yeah. I was just looking at the time on my watch. I'm 4:28. So what I want to do is we'll hit 240.87. And I think we're going to have to do a part 2 to this one, because we still have to hit working space, labeling, and grounding and bonding. And that'll probably be enough for maybe a 1-hour session or something like that. But the other change that occurred was in 24087, where that's near and dear to your heart. I know that. This was your brainchild back in the 11 cycle, I think it was, or 14.
That's when it started.
Yep. So they added performance testing for this equipment. So because and this was a panel 10 thing where they said panel 10 has what do you call primary current injection testing for ground fault protection of equipment, which a lot of people still don't do. They keep missing that fact and just pressing a button. But in any case, they said, hey, if we're doing that testing over there, 24087 is all about the electrical worker. We should be requiring some performance testing on first installation at least. And then there's obviously the 70B takes over from a maintenance perspective. But this I think this change will go a long way to making sure that a lot of these technologies will actually do what they're designed and supposed to do after the first installation at least.
Absolutely. Another big change in 24087, it's not in C, C is new, is that we required that you install a means of arc energy reduction, but we never required that you document that it would actually work.
Yeah.
And in 2020, that is a requirement.
Yeah.
I mean, you have to prove that the method you chose is going to work within the amount of arcing current that exists.
Yeah. Absolutely. And then I do this all the time. I threw in some images of some testing that might be being done. Now they did permit in 24087 primary current injection testing or an equivalent means, because some of these technologies require light, or in the case of like the arc quencher and even fuses, if you drive enough current through them, you're going to end up buying a new one. So they realized that primary current injection testing may not be either adequate or possible for some of the technologies that are used in 24087 and in 24067 as well. Same language one in both locations. So I threw in some images of, and I like this one here because they show, how they rope off the area where there's another rope off on the other side. So only qualified individuals are allowed in that entire area, which I think is a good thing. All right. So what time is it? It is 4:20. I don't know.
It's 4:31.
4:31. All right. So what I'm going to do now, Jim, is we're going to pick this up again on part 2. And I am
You have to give them their Menti code. You got to give them their Menti code.
Yep, that's what I'm going to do right now. So I'm showing the Menti code. Actually, since you're not there, I'm just showing me. So Menti code is right below. It's 803956. Thanks to Jim Dollard. We lost his video, but that's fine. We still had his brain and his voice, which is the most important part. I don't like looking at him anyway, but in any case, thanks, Jim, for sitting with us and sharing your knowledge. And I think we may have made a difference today. And hopefully when we reschedule and finish this in part 2, you will join us again for that one.
It's a holiday weekend, and I'm about 30 seconds from a Miller Lite, and I want to just wish everybody a happy 4th of July.
Yes, happy 4th of July to everybody out there. And thanks for tuning in. I'm just going to look real quick. I think we got all the questions out there in YouTube land. So that's a good thing. It's always a good thing. And I appreciate everybody dialing in and participating. And we will look forward and tomorrow. Oh, remember, do the Menti code because we're going to give away the cup. And I'm getting some more of these in, so I will be giving away more than one, but the first recipient will have serial number 1. Don Ganir says, thanks, Jim. And he said to enjoy the holiday and stay safe, all that good stuff. ShockWeek has been off. Daryl Hill's on the house. Hey, Jim, Daryl Hill's in the house.
Is he?
Yeah, Daryl Hill's out there. So welcome and thanks for ShockWeek. Thanks for continuing with me on ShockWeek. And We've got 11 likes. No one else likes us, Jim, but we got 11 of the viewers to like us. Mr. Abbasi was on too. Mather Abbasi was out there. So,
All right.
all right. So thanks everybody online. Thank you, Jim, again. I can't thank you enough, brother, for all you do for electrical safety. So,
All right. I'll see you guys.
all right. Take care, Jim. And I'm going to stop sharing my screen. All right, everybody. I am going to end this stream. I ended my meeting with Jim. Tune in tomorrow for safety by design discussion, and I'll be probably I won't. I'm going to wait till after I get everybody. And I know if you attended yesterday, I haven't gotten the PDHs out yet. You will get those today. So remember, ShockWeek continues with the official ShockWeek mug. Any event is official when you have a mug that has the event's name on it. So a lot of good takeaways. I appreciate that. Excellent, Bill. Mr. Edwards, thank you. Diego, thank you, Diego Carazo Coronado. Diego Carazo Coronado. Hopefully I got that right. Bruce B. I am working on my fire pump, guys. I'm going to be working on that one. What I might do is actually get somebody who's on that panel, which Jimmy, I believe, is on the panel. But I might try to get a few, get some other perspectives as well. So in any case, just looking through. Thanks for dialing in. So take care. Good night, and remember to stay safe and please stay healthy over these. It doesn't matter when. Just because it's a holiday doesn't mean it's any special. So stay safe and stay healthy always. But raise your attention this weekend due to the holiday weekend. Be careful driving. Be careful using your fireworks and all this other good stuff. I know we love to have fun, but please be mindful. Don't start a forest fire. Don't burn your house down. Don't burn your fingers and all that jazz. All right. So take care. Thank you. And we will see you tomorrow. Tomorrow's event will be 12 to 2. I'm almost positive. Don't forget to hit like and don't forget to subscribe to my channel. Thank you. Take care. End.